All right, in this presentation, we're going to talk about radical functions, the domain, range, and graph. So let's go ahead and start off. So we're going to split this into two different categories. We have odd roots. If your index is odd, the domain will be all real numbers. Similarly, the range will also be all real numbers. So if we look at example A, our domain is negative infinity to infinity, and our range is also negative infinity to infinity. But let's go ahead and graph this. Now you will not be required to graph them by hand, but just to show you what we're looking at. So technically I can pick whatever numbers I want to plug in for x, but I'm going to go ahead and limit it a little bit more so that we get nice values for our y's, or our h of x's. So let's work with -7, 0, 1, 2, and 9. If we plug in -7, we get the cube root of -7 minus 1, or -8, which is -2. If I plug in 0, I get the cube root of 0 minus 1, or the cube root of -1. That is equal to -1. If we plug in 1, we get the cube root of 1 minus 1, or the cube root of 0, which is 0. If we plug in 2, we get 2 minus 1, which is the cube root of 1. The cube root of 1 is 1. And finally, if we put in 9, we get the cube root of 9 minus 1. 9 minus 1 is 8, and the cube root of 8 is 2. Okay, now that we have our values, let's go ahead and look at our graph. All right, -7, -2. We're going to go 7 to the left and 2 down. 0, -1 is going to be, we do not move left or right, we're going to go 1 down. 1, 0, we go 1 to the right and stay there. 2, 1, we go to the right and 1 up. And 9, 2, we go 9 to the right and 2 up. And so now if I connect my dots, this is going to look basically like a sideways cubic function. It should look something like this. And so one of the things to note is that all of our odd root functions will have kind of the same basic shape. They will just be either stretched out or compressed down a little bit more. Okay, so then let's talk about even roots. So if our index is even, we are going to have to do some work in order to find the domain. So to find the domain, we're going to set the inside greater than or equal to 0, and solve. Remember that we are not allowed to take the square root or the fourth root or even any even root of a negative number. Our starting point is going to be 0 and continue to the positives. For now, to determine the range, we're going to look at the graph. In your later math classes, in your next math class, you will probably talk about how to calculate the range. Okay, so let's look at example B. We have f of x equals the square root of x minus 2. So the first thing I want to do is I want to calculate my domain. So I'm going to set the inside of my square root, the x minus 2. I want it greater than or equal to 0. In order to solve this, we're going to add 2 to both sides. And we get x is greater than or equal to 2. If we want this in interval notation, remember that we're going to start at 2. I want all of the numbers larger than, and so my domain is 2 to infinity. Okay, so let's use that in order to come up with our range. So I'm going to go ahead and make a table. Now again, you can pick any numbers bigger than 2, but I'm going to go ahead and limit it to numbers that are going to give me nice values. So I'm going to go with 2, 3, 6, and 11. All right, so if we go ahead and plug this in, we get the square root of 2 minus 2, or the square root of 0, which is 0. If we plug in 3, we get the square root of 3 minus 2, or the square root of 1, which is 1. If we plug in 6, we get 6 minus 2 is 4. The square root of 4 is 2. And finally, if we look at the square root of 11 minus 2, we get the square root of 9, or 3. Now again, note, you can pick any numbers you want. So for instance, I can plug in x equals 4, x equals 5, x equals 9. The only thing is that you're going to get decimal answers when you take the square root. So now, if I look at these values, keep in mind that my x keeps going down and my y keeps going down. We do have fractions or decimals in between each one of these y values. So my range, we have y starts at 0 and it continues forever. Okay, so let's look at the graph of this. Again, you won't be asked to do this, but this is just to kind of give you an idea of what does this look like when we graph it. So if we graph this, we have 2, 0. We're going to go 2 to the right. 3, 1. We're going to go 3 to the right and 1 up. And I'm going to go with 6, 2. If we graph this, we get half of a parabola on its side. And so that is going to be our basic shape for an even root. Let's go ahead and continue and see what else we can do. Let's look at example C. C, we have k of x equals the square root of 4 minus x. So for my domain, The first thing that I'm going to do is I'm going to set the inside greater than or equal to 0, and we solve. So I'm going to subtract by 4. We get negative x is greater than or equal to negative 4. And then I'm going to divide by negative 1. And recall that when you divide, multiply, or divide by a negative, you have to flip your inequality. So we get our domain is x is less than or equal to 4. So what is that in interval notation? That means I want all of the numbers to the left of 4. 4 is included, so I'm going to use a square bracket around that. Alright, so let's go ahead and plug in some numbers for x and see if we can find our range. So if we go ahead and, again, you can pick whatever numbers you want. I'm going to pick numbers that will result in a nice graph. So I'm going to plug in 4, 3, 0, and I think negative 5 will work. Okay, if we plug in negative 5, we get square root of 4 minus negative 5 becomes plus 5, or the square root of 9, which is equal to 3. If we plug in 0, we get 4 minus 0, or the square root of 4, which is 2. If we plug in 3, 4 minus 3, or the square root of 1, which is 1. And the square root of 4 minus 4 is the same thing as the square root of 0, or 0. Now remember that our x values continue to go in the left direction, but what do my y values continue to do? So if we look at this going from bottom to top, this is 0, 1, 2, 3, we're going to keep increasing our y values. So my range on this one is still going to be starting at 0, and we keep going up to positive infinity. Alright, so let's go ahead and see what this looks like. So I'm going to start graphing at 4, 0. We have the point 3, 1, and we have the point 0, 2. So this one has the same basic shape, but notice that it is going to the left this time. Okay, let's look at a couple more. Okay, so let's look at g of x equals 4 minus the square root of x plus 1. So again, I'm going to start by finding my domain. My domain, I want to set my inside greater than or equal to 0. If we solve, we can subtract 1 from both sides, and I get x is greater than or equal to negative 1. In interval notation, remember this is greater than or equal to negative 1, so negative 1 is my leftmost value, and positive infinity is my rightmost value. Okay, for this one I recommend using a calculator. we're going to go ahead and come up with our table. I'm going to start at -1, 0, 3, and 8. Those are the values that I'm going to plug in. Alright, so if we plug in, we get 4 minus the square root of -1 plus 1 equals 4 minus the square root of 0. Square root of 0 cancels, and we are left with just 4. Alright, if we plug in 0, I get 4 minus the square root of 0 plus 1. 0 plus 1 is 1, and the square root of 1 is 1, so we get 4 minus 1 is 3. Alright, if we plug in 0, we get 4 minus the square root of 3 plus 1. 3 plus 1 is 4, and the square root of 4 is 2. And I messed that up. This should be 4. Let me just try that again. We should get 4 minus 2, which is 2. Alright, last one, we get 4 minus the square root of 8 plus 1. 8 plus 1 is 9, and the square root of 9 is 3. So we get 4 minus 3 is 1. Now again, my x's, notice that they are going to keep increasing as we go down our table. What are my y's doing? Well, my y's are actually decreasing as we go down our table. My range on this one is actually going to be -infinity to 4. But just to show that, let's go ahead and graph it. Alright, -1, 4. We're going to go 1 to the left and 4 up. Zero, 3, we go 3 up. 3, 2. We go 3 to the right and 2 up, and 8, 1. We're going to go 8 to the right and 1 up. And so right here, this is my starting point. And we go down from there. Alright, so those are some examples of some square roots. Let's go ahead and look at a couple other examples now. For this one, we just want to determine the domain. So the first one we're going to look at is the fourth root of 3x minus 12. And so just like with square roots, all we care about is the inside thing greater than or equal to 0. We can add 12 to both sides. We get 3x is greater than or equal to 4. We can divide by 3 and we get x is greater than or equal to 4/3. In interval notation, this is 4/3, comma, infinity. All right, last example, we have h of x equals the square root of x squared plus 9. Now I know that I said the domain of square roots, we always have these restrictions on it. This one, if we look at it, we get x squared plus 9 greater than or equal to 0. If we try to solve this, we get x squared is greater than or equal to negative 9. Now, one thing to note is x squared is always positive or 0. It's non-negative. So when it is a positive number greater than or equal to negative 9, that is always going to be the case. And so for this one, our domain is actually all real numbers because of our inside thing being squared, because of our inside variable being squared. For examples like this, it gets a little bit more complicated in terms of graphing them and finding the range, so we are not going to worry about that at this time. Alright, so that takes care of domain, range, and graphs of radical functions.